This is lesson 8.3. The purpose of today's lesson is to learn the third and final method on how to solve a system. How to solve a system. You don't necessarily need to write this down, but you need to listen. We've done our graphing method. Generally, we use that if they intersect at the intersection of two boxes. It's easy to use the graphing method. We're not going to know that. So we generally use the graphic method when our directions say use the graphing method. Otherwise, we like to go for an algebraic approach, which generally is more accurate. Graphing is time-consuming and it's not always accurate. We learned yesterday how to substitute. If A is equal to B and B equals C, then I can substitute if A for B, because A is equal to B, right? Today we're going to learn the elimination method, where we're going to be adding up and down. If I add A plus C, it's equal to B plus D. Okay? So let's try one. Ready? Okay. So let's take our first system, and I'm going to rewrite it down below. I always want you to write the problem and then rewrite it. Now, when you're doing elimination, I want you to write it exactly the way I'm showing it, because otherwise I get so frustrated checking your work. This makes it very clear to me. And right now it's not going to make a big difference on this problem, but it will make a difference as we get further into the PowerPoint. So when I have 2x plus y equals 6, and I generally use this method when the equations are in standard form. So if my equations are not in standard form, I've got to get them to standard form. So they come to us in standard form, and then what we do is we just add these like an addition problem. 2x plus 3x is what? 5x. Positive y and negative y is what? They're additive inverses. Right? So what we do is eliminate a variable with our additive inverses, and 6 plus 4 is 10. So you with me? What just happened there? Yep. I'm adding up and down. I eliminate a variable by using my additive inverses. Next step, what are we going to do to go?
Divide both sides by 5.
Divide both sides by 5. And x is equal to 2. What do you think I would do now? You should be writing as we're going. Max. We're going to substitute it into the equation, which is?
2x plus 5 equals 6.
Is that what you're choosing? Max didn't choose it, but okay, we'll choose what Elise chooses. Max, you have, no, it's okay, but Max, you have to choose one. It doesn't matter. No, it's okay, Elise. I would choose one too if he's not speaking up. But you get to be the chooser. Do you understand? Meaning I want you guys to know that it doesn't matter which one you choose. You just choose one. Okay? Elise, is there a reason why you chose that one?
Just looks easier.
Just looks easier. Sometimes it might not. Just she chose it because she thought it looked good. So we substitute in 2 times 2 plus y. That becomes 4 plus y equals 6. Subtract the 4. And my solution is 2, 2. Now, we have 2 names for this method. Please put them both in your notes. It is the elimination method or the addition method. Means the same thing. And my poster for the elimination method just fell down. It's right there on the board. Do you guys see it? And right next to it is talking about the additive inverse that we use for the elimination or the addition method. So if you forget, they should be going right back up there. They really should be next to each other. I gotta make room for those two to be next to each other. And you see, I also have a system of equations. Down here, we're really getting into the system of equations. There's a system of equations using substitution method. Here's graphing. And elimination should go right here. And I really should have that additive inverse right next to it because that's what we use. And then you'll see, here's the graphing. We're going to eventually get to that. So we've really almost gone through this whole row. Thanks to my cousin for putting those up. Okay, so is everybody clear? Okay. All right, and when you check, remember this point should work on both of them. So if it's 2, 2, then we're doing 2 times 2, does 4 plus 2, does that make 6? And does 6 minus 2 make 4? So it works. All right, let's try the next one. You guys want to try this one on your own?
Yeah.
Pause the recording. Okay, so what do I do first, Noah?
First you rewrite both of the equations.
Good.
And then what I did is I used additive inverse and I got rid of x because it equals 0.
Good. And you ended up with?
4y equals 5.
Yeah, that's where you went wrong. Remember, when you're doing this, these cancel. You're adding up and down here. 4y equals what?
Oh, 8. Yeah,
8.
that's what I messed up.
So divide by 4, and y is equal to 2. So then, what would you do?
Then you would use substitution and you use the other equation. I use negative x plus y equals 3. And so what you would do is negative x plus 2 equals 3. Then you would subtract 2 from both sides and you would get negative x equals 1.
Negative x. That's supposed to be an x. Negative x equals 1.
Then you would multiply both sides by negative 1. And you would get x equals negative 1.
Perfect.
Don't you have to divide it?
It could be, the only exception is with negative 1, you could just multiply. Multiply or divide, you'd get the same result. It's taking the opposite of each term. So you end up with negative 1 comma 2. And you do need that. Oh, that doesn't go in braces. That goes in an ordered pair because it started with variables in an equation. So you do need it in that order. Okay, questions? All right, let's try the next one. All right. Solve. Okay, now this one's slightly different. And basically, I'm going to need to take y equals 3x plus 4. Now, I want you to write this the same way I'm writing it. Okay? And I'm going to have to change it to standard form. So what do I have to do to get it in standard form? Yeah.
Subtract 3x from both
I'm
sides.
subtracting that 3x, subtracting 3x. So it ends up being negative 3x plus y equals 4. You guys with me? I'm showing the arrow, and then the other equation, I'm just going to show the arrow. It's staying the same. Now, Julia, what do I do?
You add negative 3x
And what do we get?
negative 1x, and then since the positive y and negative y are opposites at 0, so
What does that mean? They're opposites. What's the definition? What's that up there? What's the word we use for negative y and positive y? I just pointed it out to you. Yes.
additive inverse.
They're additive inverses. Can everybody say that?
Additive inverse.
So one more time. Start over your conversation.
So you add negative 3x and 2x,
And you get?
negative 1x,
Good.
and then y and negative y are additive inverses, so 0,
So they cancel.
and then you add 4 and 5.
Good. And then we multiply by -1, and we get x equals -9. And what would I do next, Julia?
Then you would choose an equation. So just do the 2x minus y equals 5.
Okay. And somewhere in your notes, make sure you have this down. Put both in standard form before you can eliminate. Okay, which one did you want to do?
The second one, 2x minus y equals 5.
Usually when it's like something's alone, that's going to be easier math, but because you're not going on each side, you just simplify. But I'll do this one. 2 times -9 minus y equals 5. -18 minus y equals 5. Add 18, add 18. -y equals 23. Multiply -1, and I get y equals -23. Did I do that right?
Yep.
Like you'll see, I went to the easier one. See, I just simplify on that side, not move it from side to side and solve. Okay, questions? All right, sometimes I have two equations, and there's nothing that's going to be an additive inverse. There's nothing that's going to be an additive inverse. So I have to manipulate one of the equations. Which equation am I going to manipulate? What would be the easiest? Yep.
2x plus y equals -4. I mean, sorry, 3y.
I think that is already needs to be. What I want to do, what I say to myself is, I want to make an additive inverse. What's the easiest? I think this one is. If I make these additive inverses, I have to multiply this by something and this by something. But if I choose to make my x's additive inverses, then I only really have to manipulate one equation. Okay? Which equation, what am I going to have to do to make these x's become additive inverses? Everybody? So I'm multiplying that whole equation, the whole equation by -2. Not the first one. They're showing you it doesn't work. That was it. It's like, oh, this makes 3x, nothing eliminates. Okay, so we're going to take the whole bottom equation. I'm going to multiply by -2 and carry it over. The top equation stays the same. Write it as I'm writing it. I want you to show me these arrows, okay, guys? Because if you just keep rewriting it like this, 2x plus 3y equals -4, and -2x plus 8y equals -18. This is really supposed to be this. And this is really supposed to be this, and it's too hard to see it. Do you understand that when I'm checking your work? So please draw the arrow to the side. Just makes it a lot easier. Get your test back faster. Okay, now I'm ready to, what are these called, Julia?
Additive inverse.
So I'm going to cancel my additive inverses, and then I'm left with plus 22y, sorry, plus 11y, and equals -22. Divide by 11, divide by 11, y equals -2. Now, -2, I substitute into either original equation. Which one do you want to substitute? How about Julia?
The second one.
Yep, I like that one better too. 4y equals 9, and I'm doing x minus 4 times -2 equals 9, x minus plus 8 equals 9, subtract 8, x equals 1. So this would be 1 comma negative 2. Do you understand when to put it in parentheses and when not to? All right. One more problem, I think. I'm going to skip this one right now. I want to make sure I get to this other one, and if we have time, we'll come back here. Okay, so look at the equations. What's going to be the best? What do you want to make additive inverses? Noah?
Would you manipulate the first one?
So you want to get rid of, you want to eliminate the x's?
Yeah.
Okay, we can do that. Does anybody want to eliminate the y's? We can. There's no wrong way here. Because when I manipulate the equation, no matter what I do, there's no additive inverses. So if I'm going to eliminate the x's, I would have to multiply. What would be the least common between 2 and 5?
10.
10. So I'm going to have to multiply by 5 here and 2 here to eliminate those x's. But that doesn't mean that I have to do that. What if I had chosen to eliminate the y's? What am I going to multiply the top one by? 2. And the bottom one by? 3. So you have the ability to manipulate one or both of the equations. You have the ability to move one of the equations into standard form. So you can solve using elimination. Let's go with what my PowerPoint's going with. They're going to eliminate the x's. So when I multiply everything by 5, Chloe, what do I get?
You get negative 10x plus 15y equals 25.
Good. And keep going. And then the next one, let's go, Isabel? What am I going to multiply it by? To make it, my goal is to make this opposite of this. My goal is to make that 5x. So what do I have to multiply the whole thing by? Negative 5. So negative 5 times 5x will make this the opposite. That's 25x. Negative 25x. That's not the opposite. What do I have to multiply the 5 by, 5x by, to make it the opposite of negative 10x? Negative 2. So if I'm multiplying by negative 2, what do I end up with? Negative 10x. What? Is that opposite? Doesn't cancel. Positive 2. I'm multiplying the whole thing by positive 2. And then I get what, Isabel? 10x minus 4y equals 8. Cancel. And then I'm left with, that would be, sorry, I cannot even think, 11y equals 33. Divide by 11, divide by 11, y equals 3. Okay, now what? Tony, what do I do with that y?
You choose an equation.
Either original,
Negative 2x plus 3y equals 5.
and I substitute in. Negative 2x plus 3 equals 5. I'm substituting in 3 for the y. Negative 2x plus 9 equals 5. Subtract 9, subtract 9. Negative 2x equals negative 4. Divide by negative 2. And we have x equals 2. Let's see if that was right. So it'd be 2 comma 3. So again, what was the purpose of today's lesson?
Solve linear equations using
One person, let me hear. Okay, go Elise.
Solve system of equations using elimination or the addition method.
Perfect. What happens if they are not in standard form? What do? Go, Daisy.
Well, we convert them to standard form.
Right, we convert the equation to standard form and then use our elimination method. What happens if, when I'm looking at the system of equations, there are no additive inverses? Go, Mike.
You have to multiply one equation so that if one of the x or y is an additive inverse.
Right, one or both equations to eliminate either the x's or the y's. Does that make sense? And that's the end of the lesson.